in our HD map, which is this concept of a driving path. You can think of a driving path similar to a road lane, but it's just a single linear path that we've observed cars driving in a scene. And you can think of it as rails. It's like a monorail that as long as our car drives on top of this path that all the other cars are going on top of, we're good, right? And it turns out it's a really important piece of our map, but driving paths can change too over time. And that's sort of what this little video is showing. We're essentially accumulating trajectories of cars that we've observed at an intersection. I'll play it one more time, over and over again. And this particular example doesn't show it, but you can actually see these driving paths change over time. So there could be a snowbank on the side of the road. There could be some construction happening here. As those driving paths shift, we want our self-driving car, we want the rail that it's driving on top of to shift as well. And this is something that computer vision is actually super helpful with, because if you're asking a human to look at the road to figure out where that driving path is, without perceiving some of this historical data, it's actually really hard to detect some of those subtle changes in the world. And finally, computer vision for what I call backup systems, or onboard mapping, online mapping, real-time mapping. Essentially teaching the car to drive with no map at all, in a way that it's a protective backup system. So again, we don't have the attitude that this is where we start. We have the attitude that this is something we have running just in case something changes around us. And hey, maybe at some point it gets good enough to where we don't even need this map in the first place. But for right now, this is a safety system that we have protecting us. It's pretty cool too, right? It's pretty awesome when you can do things like this. All right, so how do we make sure the holes don't line up? Am I good on time?
Yep.